Hey, hi everyone. So today we are going to see a basic principle of OOPS. So what is OOPS is? OOPS stands for Object Oriented Programming, and they have decided certain principles, and those languages which follow those principles will qualify for object orientation programming language. So for example, C++, Java, Python, .NET. These are some of the examples of your object orientation programming. Now, whenever we see object oriented programming, the focus is on object. Now, what an object is? Object is nothing but your data. So, if you focus on the data, if you focus on the security of the data, it means that you are on the path of object orientation programming. So, how to secure my data, or what exactly the object is, how I can identify that what is object, what is not an object. So basically, whenever we talk about object, so the definition says that anything that exists in the real world is object. It means that if I can see that something is exists in the real world, we can treat it as an object. For example, marker, I can see the marker, so marker is an object. Pen, I can see a pen, so pen is an object. Then board, I can see a board, then it is a object, right? Person, I can see a person, so it is an object. But there are certain things which exist but we cannot see. For example, time, or I can say air. So air exists, time exists, but these are some entities which we cannot see. So those are also considered as object, but those are under the intangible category, and those which we can see comes under tangible category. So tangible object means those objects which can be seen. Intangible objects are those objects which cannot be seen. But anything that does not exist does not qualify for an object. So object can be categorized as if it exists in the real world, either in a hardcore format or in an imagination format, it is a object, right? Now, every object have some categories. For example, every object have a state, every object have some behavior, every object have the identity, and every object have some responsibility. Alright. So what a state of an object is? Suppose if I take an example of person, then every person have some attribute like age is there, name is there, right? So these are the attributes of a person. Now if I assign the value to this attribute, let's take the age is 20, the name is Raj. So when I assign the value to the attribute, it becomes, the complete thing becomes state of an object. So whenever a value is associated with the attribute, it becomes state of an object. Next one is behavior. So how the object behaves with the outside world is known as behavior. For example, if a person is a student, the behavior is kind of a student. The behavior is studying. If a person is a businessman, then he is doing some business. That is the behavior. If a person is employee, he is doing his job. So that is the behavior of a object, right? Now in terms of identity, so we will also see this in terms of a real example, right? So we'll come first for identity. Now what identity is? So identity basically a uniqueness which represents an object. For example, whenever I say person, there might be some unique feature with this person. The Aadhaar card, that is unique to every person. The thumb impression, that is unique to every person. So this must be a unique feature which specifies the particular object, or which differentiate that person with other persons. So that is identity. And responsibilities, basically it is a kind of uh, similar to your behavior, but in terms of responsibility, the definition says that if the object is responsible for anything, then only it get exist. If an object is not responsible for anything, that means the object must not exist. So this can be understood with the next example. Let's take pen. So if I have pen, so the price of a pen, the company name of a pen, and let's take, there is some barcode, manufacturing date. So these are some attributes. When I assign the values to the attribute, it becomes my state. So the price is, let's say, 10 rupees, the company name is, let's say, Reynolds, the barcode is something 1234, manufacturing date is something, let's take August 24 something. So this becomes the state of an object. Behavior, what is the behavior of pen? Is writing. So writing becomes the behavior of an object of the pen. Identity, the barcode which is unique to every pen, is becomes the identity of the pen. Responsibility, so there are pen available in the market, but why should I purchase the pen? If I need the pen for writing purpose, then only I will purchase it, otherwise I will not purchase it. It means if there is some responsibility, then only I will go to the market and I will purchase the pen. If there is no responsibility of the pen, then I will never buy a pen. So that comes with responsibility, right? Now these are some real-time example, but what if I come to the programming side? Then how I can see this in the programming? So whenever we see a programming, whenever we in the programming we create an object, right? So in object there are certain fields what we are discussing. So all the attribute of that particular object will be allocated the memory. So memory gets allocated to all these fields, right? And whenever you assign the values to these fields, it becomes the state. So for example, let me draw this just kind of example. Let's take employee is there who have a id, who have a name, and who have some salary. So this is my object of employee. So this is my memory where I have three sections. One is reserved for id, one is reserved for name, and one is reserved for salary. Now whenever I store the value to this memory section, this becomes the state of an object. Behavior, so using this object, how many functionalities I can access, that is the behavior of the object. Identity, every object have a different name, or every object have some random address, that becomes the identity. Responsibility, why should I create object? Because I need this object, then I will create it. I do not need any feature, I do not want to call any feature, then I will not create an object, that becomes responsibility. So basically this is a basic of your objects. Now coming to object orientation. So object orientation have some minor and some major principles defined. So major principles are the mandatory principles, and minor principles are those principles which may or may not present. For example, if we talk about the minor principle, so strongly type is the first point. The second point is persistence. The third type is concurrency, right? So strongly type means if suppose I have a variable a, right, and I assign the value 10.5 to this. So ideally in C or C++, if we are taking the same example, what will happen that 10.5 will get assigned to A, but compiler will automatically delete this 0.5. Compiler will convert this decimal value to a normal integer value and it gets assigned to A, right? But what is happening here is I am losing my data, but compiler is not giving any warning, neither it is giving any error that you are losing the data. So the developer is not aware about this, and blindly if he do this, then the data will be lost. So it means that this is not a strongly typed language. But whenever we talk about strongly typed language, Then if I write down like this, for example, in java.net, if I write down the syntax like this, the compiler will give you an error that the decimal value cannot be assigned to an integer value. So either you have to remove this manually or you have to change the data type. So this is known as strongly typed language. Next one is persistence. The meaning of persistent means permanent, fixed. So if the language supports something that is a permanent or a fixed, then that language is persistent. For example, file IO or database. So most of the languages supports file IO as well as database. Even your C++ also supports both. So file IO means I can write down into the file and the file will be available if I shut down my laptop as well, right? Same goes with database. The database also I can use to store some data which will be permanent. If I shut down my laptop, if I on it after 5 days or after 5 months, still I can see the data available, right? So this is known as persistent behavior. Concurrency is basically it relates with multiple processing, or you can say multiple threading, multi-threading. So it means that suppose I have function 1, I have function 2, and I have function 3. All these functions are independent. It means they are not dependent on each other. Now, if I normally run the code, function 1 will execute. Once function 1 will get completed, then 2 gets executed. Once 2 get executed, then 3 gets executed. Right? But using concurrency, what I can do is I can run 1, 2, and 3 parallelly at the same time. So this behavior is known as concurrency. Right? Now we'll see some major principles. So these are some principles which might not be present, which might be present, right? So that is a optional thing, but major principle means it is mandatory. So the first one is abstraction. So if any of the principle from the major section, if it is not present, then the language cannot qualify for object orientation programming. So abstraction. Second one is encapsulation. Third one is inheritance. Fourth one is polymorphism. So what abstraction is, most of us will already know it by definition, that hiding the complexity and showing only the essential feature is abstraction, right? So ideally, whenever you create a function, for example, if you are creating a class with some random name, and if you write down any function within this class, right, this is public. So basically this function is within the class. Now from outside the class, if I want to access this function, I only need is the function name, the object to call this function, right? That's it. And if there are any parameters, I will pass the parameters. Now what will happen is, I do not know what is there inside the function or how the function executes the logic internally. What I am aware is only the name of the function and the parameters I want to pass, right? So this is what abstraction is. So we are only exposing the essential things and the complexity is hiding behind. For example, let's take this function is to calculate a Fibonacci series. Now what I want is, I will only call the function, that is the name of the function I need. If there is any parameters, that parameters I need to pass, and I am done. How the Fibonacci series gets generated, how it gets calculated, how it gets printed, I am least bothered about that one. So that internal complexity is hidden. What I am exposing or what I am getting is the essential things. So that is what the abstraction is. So hiding the complexity. Same if you take the real time example, if you use calculator, then you have some buttons on the calculator, right? So you can press 1, then plus, then 2, and then equal to, you will get 3. But how this, when you are pressing the buttons, what internally mechanism is working, you are least bothered about that. Whenever you are driving a car, you know how to accelerate it, how to brake it, how to change the gear, how to use the steering. But what mechanism is implemented internally inside the engine, how it is working, that you are least bothered. So that is what best example of your abstraction. So the car company have exposed only the essential things which is required to drive a car, but the internal complexity is hidden inside the bonnet. So that is abstraction, right? Same if you want to cover the same example in your programming thing. So the functions what you are writing, so the function what you are writing is the complete function, but who is using your function, those people only need the name of the function, the parameters they need to pass, and what you are returning back from the function, that's it. But how the function internally working is hidden. So that is abstraction, right? Now encapsulation. Now encapsulation, as the name suggests, if you are encapsulating something or if you want to protect something, then you will encapsulate it. So if you have seen the tablets which we sometimes get from the medicine, it will be like this something, and all the medicines are inside that capsule, right? So if you open it, you will see that medicine is there, or the powder is there, or some uh, small dots will be there inside that one, right? So basically this capsule is protecting that medicine which is placed inside. So that is what encapsulation is, right? So encapsulation is wrapping the data and functions into a single unit becomes encapsulation. And why we are doing this, why the medical facility is providing a capsule and they are putting the powder inside it, why they are not directly providing the powder either in some sachet or something like this? Because that is, they want to protect it from the outside atmosphere. They have some proper measurement which only needs to be taken, so that's why they have done all these calculations and they have put it in the capsule, right? So in the same way, when we have suppose data, for example, let's take, I have a person, so I will create something like this class person. Now what is the attribute of this person is, so what is the attribute of this person is, let's take, I have integer age, right? I have some string name. What are the functions of this one? Let's take set the age function is there with some integer age. Then I have, let's take set name, right? So these are certain functionalities. Now what I have done is, I have the data, I have the functionalities, and I have put all these things inside a opening bracket and closing bracket, which is nothing but my class. So class is basically the example of encapsulation. So creating a class, it means that you are encapsulating the data and functionalities. So I am putting my data and my functions into a single unit, that is nothing but a class, and that is what a encapsulation is. Now why we are doing this? For the security purpose. So now if I want to access this data, since the data is private or the data is kept inside the class, it cannot be directly accessed outside. Since the functions are already placed in the class, it cannot be directly accessed outside the class. So how can we access it? Using the objects, what we are going to see in the upcoming session, right? So this is encapsulation. Now inheritance. So what inheritance is? Basically inherit means taking the property of one to another. So if you already have the properties defined, then what we say is, do not recreate the same properties again and reuse it. Or if you have heard the phrase like, do not reinvent the wheel. right? So the same thing, we are not going to reinvent the wheel. Instead, we are taking the wheels and we will add on our new properties to that, so that the efficiency becomes much more. For example, if there is already a class calculator which already have functions like add, then the functions is subtract, divide. I'm not writing the complete syntaxes. Once we start with the programming, then we will come through the syntaxes and all that. So we are just focusing on the concepts part. And let's take multiplication. So suppose I have a class calculator which supports these four functions, these four functionalities. I can add the numbers, I can subtract the numbers, divide the numbers, or multiply the numbers. Right now, if I want to create one more class, let's take I want, so this is, let's take person one develop this class, right? And he have some clients, those are using it. Now I have a requirement to create a scientific calculator. So now what a scientific calculator will do, it will provide some additional functionalities like calculating the square root, then cube root, right? Some sine cos functions, sine cos tan something. So these are the functionalities. But the scientific calculator is also capable to add, divide, subtract and all that, right? So if I do not inherit anything, I have to recreate all these function, add, divide, subtract, multiply, right? But since it is already developed by someone, what I will do is I will take that features from this class to this class. So what I will do, so this syntax is of Java, so I will extends calculator. It means that we are inheriting calculator in scientific calculator. It means all these functions which are developed by calculator class is also available in the scientific calculator class without creating anything. So what I will do is I will only create the new one, the new functionalities. The rest I will get again from calculator. So in scientific calculator, I can calculate square root, cube root, sine, cos, tan, as well as I can add, divide, multiply and subtract. So which I am getting from my other class, right? So the topmost class which is providing the data or which is providing the functionality is known as base class, and the class which is inheriting those properties or which are taking the properties, that is known as derived class. So inheritance is basically used for code reusability. So I'm reusing the existing code, I'm not recreating the code again. That is reusability feature, right? And inheritance always show is a relationship. It is also known as is a relationship, right? Okay. Now the next thing is our last point, that is polymorphism. So polymorphism means a single message having a multiple kind of implementation. For example, whenever I say polymorphism, now there are two types of polymorphism can be achieved, right? One is compile time. I can achieve a compile time or I can achieve it at runtime, right? Now, even in this section also, these two things can be achieved using overloading. So in polymorphism, I can do overloading and I can do overriding. So what a definition of overloading is, the name of the function is same but the parameter is different. For example, if I have add, let's take I have to add two numbers, so I am keeping the name add and I have two integers. Now if I want to add three integers, so again since I am already performing additions, I will keep the name same and I will name this like this. So whenever someone pass two parameter, this function will get called. Whenever someone pass three parameter, this function is called. So the name of the function is same but the parameters are different. It means this is known as overloading. Now the next thing is why we need this overloading. And why we need to keep this name same? So basically it is just to avoid the confusions. For example, if I want to do perform addition, so if I'm already performing the plus thing, right? So whether I have to add two numbers or three numbers or five numbers, I'm doing the task, that is addition. So if I'm doing the same task, then as per the polymorphism rule, the name must be same. Keep the name same so that whoever is using your functionality, they don't have to remember different varieties of name. So they can only use this name that add. If they pass two parameter, this get called. If they pass three parameter, this will get called. Since both the working is kind of a same thing, so we keep the name same. Now overriding comes in picture when we have a inheritance, because this cannot be achieved without inheritance. So overriding means if there is already a functionality, right? And if I want to hide the functionality and I want to recreate a new functionality, right? So if you want to hide a previous functionality and expose the new one, then overriding comes in picture. Overriding, as the name suggests, we are overriding something, we are overlapping something, right? So as per the definition, overloading means name must be same, parameter must be different. Overriding means name must be same, even the parameters must be same, and even the return type must be same. So everything must be same in overriding, right? So this is it for this class. We'll see all these things in the upcoming sessions, right? So thanks guys.